All right, so welcome to the video lecture series on Introduction to Computer Networks. This is part two of our lecture topic on wireless LANs. So let us jump to the point where we left off. All right, so in wireless networks, all communication is facilitated through what we referred to earlier as wireless links. And there are many different technologies which allow wireless communication, but however, to make sure that we understand the functional properties of each of these types of wireless links, there are the standards that we need to follow. The IEEE standard, the common standard for wireless links, is 802.11. 802.11, and as you can see, there are many different versions of 802.11 wireless links. There's also the 802.15 and some other versions as well, where you can also see the WiMAX and the CDMA cellular network and GSM cellular network, all of these others. And if you look at the comparison of these different wireless links, the y-axis is showing the data rate, and these are in megabits per second. So the ones which are up here are around 200 megabits per second, and in the x-axis it is showing the range of these particular radio links. So one thing, if you notice here, is that the shorter the range, the higher is the max bandwidth. And that is more common for our indoor networks. There are other networks, for example, the GSM and the CDMA, which are more common for cellular communication. So they have long range reachability, but much lower maximum bandwidth compared to our home wireless networks. So that is a certain property which we can relate to something that we mentioned earlier. That is, the longer the range, generally the smaller the maximum data rate. So wireless links, they have certain limitations in the way they function. So these are the four primary limitations of wireless links. First is what we call as signal attenuation, which means that the strength of the signal decreases the longer it propagates through a certain matter. In most cases, that is air. And in a simple terminology, we can refer to it as path loss, and it's something that we have probably experienced as well. For example, when you are further away from your home Wi-Fi router, the less signal you get. So that particular feature or limitation is called signal attenuation. Next, the next limitation for wireless links is referred to as interference, and this occurs when there are other devices which are operating at the same wireless frequency for the obstructed wireless device. And all of these are standard network properties, right? So something that we have just seen in the previous slide, that there are these standard wireless link technologies, and they operate within a certain range of frequencies. So in most cases, you will see that a lot of devices are operating within the same range at the same time. And therefore, whenever there's a packet being transferred to the wireless link, the other wireless links which are operating within that range creates an interference and degrades the performance of the wireless link. The next limitation is multipath propagation, and this means that wireless links, is a form of wave, and it propagates in multiple directions as it travels. So, for example, if we have a point source of light, the light travels mostly in that direction, but there are losses in some other directions, right? Something that you can probably see if you are, throwing a flashlight on a wall. The further you go, the larger is going to be the circle that you see on the wall. The same thing happens with wireless link propagation as well. So if you have a wireless access point, which is allowing you to connect to the wireless network. So the wireless links, they actually propagate through matter and they dissipate further and further in multiple directions. And that is also the reason why it weakens as it propagates further through the matter. So in the process of multipath propagation, it reflects of multiple objects, bounces off the ground, gets stopped by some objects, if there's a concrete wall in the middle, and they arrive at the destination at slightly different times. So the waves which travel from the source to the destination come through different paths. Some are weaker and some are stronger based on how each of these waves traveled. And finally, the one of more of the protocol-based limitation is that wireless links need to operate in a shared bandwidth format, which means that they are always operating in half duplex mode, which means that it cannot send and receive at the same time for a given frequency. Which means that, let's say we have an access point which is operating at 2.4 gigahertz frequency, and at a particular moment, if there is a transmission which is going on from a network node to the access point, no other devices for that range will be able to use that frequency to send or receive any more packets. So this concept of shared bandwidth is one of the primary limitations of wireless networks. So far what we saw were the limitations, particularly for the type of connection, that is the wireless radio connections that we see for wireless links. So now, the way that we set up networks might also have certain limitations. So if you consider the wireless network limitations, the first thing that we would like to emphasize on is the hidden terminal problem. And in this case, what we see is that, let's say we have a node B which is within the range of node A. That means node A and B can hear each other. And we have another node C which can also hear node B. However, node A and B are outside of the range from each other. So that means that A and C are unaware of the fact that they have an interference at B. So let's say we have an ongoing transmission from A to B, and exactly at the same time, if C is trying to send something to node B, there will be collision of the packets at B. And that happens due to the lack of knowledge that A and C cannot, or they do not know that they have an interference at B. So this particular phenomena is called the hidden terminal problem. The other side of the coin, in terms of the name, is the exposed terminal problem. And in this case, we have to consider four nodes here. So let's say we have two nodes. source 1 and source 2. And as you can see from the diagram here, so source 1 and receiver 1 are within the range of each other, and there is an ongoing transmission from source 1 to R1, right? And the other thing is that source 1 and source 2 are actually within the range of each other. So that means that source 1 and source 2 can sense the use of frequency if it is being used or not. So if R and 2 are out of reach of each other, that means R1 and R2 are far apart. However, S1 and S2 still can hear each other, and we see an ongoing transmission of S1 to R1. S2 will see that S1 is actually using the frequency at the moment. So it will feel that it needs to wait even if it wants to transmit something to receiver 2. And this does not make sense because R1 and R2 are actually out of range from each other. So there should not be any form of interference even if S2 decided to transmit. However, just because of the way wireless networks work, that is, in the half duplex mode, and they need to wait if the frequency is being used at the moment, S2 will keep on waiting until S1 finishes its transmission to R2, and then only can transmit to R2. And this particular problem is referred to as what we call the exposed terminal problem.